The purpose of this tutorial is to instruct you on how to use Resistome Tracker. Resistome Tracker is a tool that can be used to explore antimicrobial resistance, stress, and virulence genes present in the genomes of different organisms submitted to the National Center for Biotechnology Information's pathogen detection. Let's get started. The home page of Resistome Tracker is a table of contents. To navigate to each of the following pages, you just need to click on one of these buttons. Let's click on the button for the quick facts page. Each page within Resistome Tracker is set up in a similar manner where there is an information icon that tells you a little bit about the dashboard, a home button to navigate you back to the table of contents, and a series of filters so you can view data of interest. The quick facts page shows a summary of the isolates that have been submitted to pathogen detection based on the filter selections. Resistome Tracker includes Salmonella, E. coli, Campylobacter, Enterococcus, Klebsiella, and Staphylococcus isolates. And this first filter is where you can select which of those bacteria you want to view. The next filter is where you can change whether you look at AMR, stress, or virulence genes. We are currently looking at AMR genes found in Salmonella. This next filter is where you can select a specific class of genes. And then you can take it one step further and look at a specific gene using this next filter. The surveillance program filter allows you to look at just the National Antimicrobial Resistance Monitoring System, the Veterinary Laboratory Investigation and Response Network, or the PulseNet isolates. And this last filter allows you to look at a specific single nucleotide polymorphism cluster if there was one that was of particular interest. Because I haven't made any further selections, the dashboard is looking at all Salmonella isolates in pathogen detection, regardless of class, gene, surveillance program, or SNP cluster. There are over 583,000 Salmonella isolates currently in pathogen detection. And here you can see the collection timeline of these isolates. The first known collection date was in 1900. And the last is in 2024. Below that, there is a series of charts that highlight the top source categories, the top serovars or species, the top countries, and the top genes. We can see that most Salmonella isolates in pathogen detection are from human sources. They are serovar enteritidis. They are from the United States. And most do not contain any AMR genes, which I can tell because the top gene is null. All of these charts are customizable, so if you wanted to look at the top 5 instead of the top 10, just type that in here and hit enter, and the chart will change. And if you only wanted to view data for a particular collection year, you would just select a point on the timeline, and the rest of the visuals on that page would filter accordingly. The last feature I want to point out on this page is if you would like to know what sources make up each of these source categories, you could click on this question mark, and it will take you to another page where it maps out each of the sources to the corresponding source category. Now I'm going to navigate back to the table of contents, so we can move on to the next page. The next one is the number of isolates by geographic location and source. So I'm going to navigate there by clicking here. This page shows the number of isolates submitted to pathogen detection by geographic location and the source category. Again, we have the series of filters at the top and then the visuals below. The first visual is of a map showing the number of isolates by country. And then below that, there is a chart showing the number of isolates by source category. I'm going to scroll back up and use the bacteria filter to look at Campylobacter. And a new filter on this page is the cerevar or species one. So if I wanted to look at a specific species of Campylobacter, I could use this filter. I'm going to move to the class filter to look at isolates containing quinolone AMR genes. That. And then I'm going to skip on to this last filter, which changes the year. Right now it's showing all years, but you can click here or use the slider to go year by year based on what is in the collection date field in pathogen detection. Please note that the collection date is a free-form field in pathogen detection, so it is up to the submitter to type that in, and the date could be missing. There is also the option to look at the year from creation date, which is automatically generated when someone submits an isolate to pathogen detection and is always available. Looking at the map, if you hover over a country, you can see the exact number of isolates. And if I wanted to see if there is any state level data, I would just click on that country and the state level data will appear to the right. So I'm going to look at the United States. And I can see that so far there have been 365 isolates submitted in 2024 from the US. And now I will click and see the number of isolates by state. If I wanted to see how many isolates from Texas have been submitted so far in 2024, I would just hover over Texas. And I can see so far there have been 41 isolates submitted in 2024. Looking below the map, the number of isolates by source category chart was also filtered when I clicked on the US. If I didn't want to see the state level data, I could just collapse this by hovering over country and hitting the minus button. And now I can see the totals for the United States by source category. So most of the isolates have been from either chicken sources or human sources. If I wanted to see further details, I could click on a bar and a button will appear that says click to see isolate details. And if I click on that, it will bring me to another page where I can see the further details. I can see the SNP cluster, the biosample, the cerevar or species, the surveillance program, and the source category. I can also see the country, the state, province or region, the collection date, the creation date, and finally the genotype. So a lot of these look like they were collected by the NARMS program. And they were collected in either 2024 or 2023. One additional feature is if you click on one of the biosamples, it will give you a link to pathogen detection, so you can view even further details. So now I'm going to go back to the home page and move to the next page, which is the distribution of isolates. This one allows users to see the distribution of isolates submitted to pathogen detection based on the source category, serovar or species, gene, or year. Again, this one is set up with the same series of filters at the top. Let's say I was interested in looking at E. coli this time. And exploring any with colistin AMR genes. So I changed the bacteria to E. coli, and now I'm gonna change the class to colistin. So looking at the distribution, the default is to show the genes by source category, but there are these toggles below the graph where you can change the x-axis and the section of the bars. So I'm going to change the x-axis toggle to year. And now I can easily see that from around 2016, this MCR 1.1, indicated by this blue section of the bar, has accounted for most of the genes, specifically most of the colistin resistance genes seen in E. coli. Right now, the year is set to look at the collection date. So this is when they were submitted to NCBI, but I can switch this to collection date. I can see the isolates by the collection year. And again, it looks like MCR 1.1 is accounting for most of the resistance genes. The last feature on this page is the ability to look at isolate details by clicking on a section of the bar. So I'll click on here, and that button will appear again saying, click to see isolate details. So I'll click on that, and it will take me to that additional page. And again, if you click on a biosample, you could link out to pathogen detection. So that is the distribution of isolates. So we can move on to the next one, which is the genes of interest. This page highlights the isolates that have been submitted to pathogen detection that contain genes the NARMS program deems of interest. The NARMS program has developed a set of criteria, which is laid out here. And if an isolate meets any of those criteria, it will be pulled into this table. And again, users can view data of interest using the filters at the top. This one is a little different where you can look at a range of dates. So for example, right now we're looking at the number of isolates containing these genes of interest that have been submitted to NCBI within the last 30 days. But you can change this to whatever range of time you want to do. So if you wanted to look at, let's say, the last 3 months, you could do so here. So I would look at months and then type in 3 and enter. And now that table has changed. The table itself is broken out into class, gene, source category, and then tells you the number of isolates. You can see where the isolates were found by clicking on a bar. Let's click on this one. And a map will appear below showing the number of isolates containing that specific gene by country. If the state level is available, you can click on the country and the state level data will appear to the right. In this case, we don't have that information. If you wanted to see isolate details, after you click on a bar, if you hover over that same bar, that button will appear again to click to see isolate details. And it would bring you to that additional page. So now we can go back to the table of contents. And for these last two pages, that filter that allows you to choose between AMR, stress, and virulence genes that has been on every other page I've shown so far is not available. You can only explore isolates via AMR genes. The first one is the percent of isolates by source and year. This one shows a graph of the percent of isolates submitted to pathogen detection containing a specific class of AMR genes by source, category, and year. Just a note, the graph on this dashboard should be interpreted with caution. The percentages shown only represent the isolates that have been submitted to pathogen detection and do not necessarily reflect global patterns of AMR. So right now, we are looking at the percentage of isolates containing quinolone AMR genes. So I'm going to switch it and look at the macrolide AMR genes in Salmonella. And then I'm going to switch which source categories are appearing using this filter. So right now, chicken, cow, dairy, and eggs are selected. I'm going to unselect eggs and chicken, and then select beef and hit apply. And now the graph has been updated, and I can compare macrolide resistance seen in these isolates over the years. When I click on a data point, I can see the specific genes that account for that resistance. So for beef in 2021, if I click on that point, it looks like MPHA accounts for most of the genes these macrolide-resistant beef isolates contain. And if I wanted to look at isolate level details, again, I would just click on the bar and click to see isolate details, and it would bring me to that additional page. So now on to the last page. Percent of isolates by geographic location. And this page is very similar to the number of isolates by geographic location, but for this one, you can't drill down to the gene level. And the bar chart below the map shows the number of isolates by gene instead of source category. So this time, let's look at Enterococcus. And specifically, let's look at isolates from any chicken sources. And see the percent of isolates containing macrolide genes by country. I can now click year by year using this last filter and see how the percent of isolates has changed over the years. Or I can use this slider and move to a specific year, like 2019. And I'm going to look at China. So we can see that in 2019, looks like around 84.4% of chicken isolates from China contained macrolide resistance genes. And now I'm going to click on China to see if there is any region level data available. And there is. So again, below the map, there is the distribution of genes. And I can see that ERM-B is accounting for the majority of this resistance in the Enterococcus isolates from chicken sources in China. And again, to see isolate details, I'm going to click on the bar. And it will take me to the additional page. And that is Resistome Tracker. Thank you for watching this tutorial.